My name is Joseph Meadows. I'm an assistant professor at Virginia Tech in the Department of Mechanical Engineering. A prototype behind me is used to solid adsorbents to absorb toxic emissions coming out of power plants, and so we will demonstrate the feasibility. And this facility has the ability to generate boundary conditions relevant to what a system like this would see if it was installed downstream of a power plant. We can't really see inside the system, but inside there's a system of louvers, and up top those columns will deposit the solid adsorbents. A patented system called a puffback system that can replenish these on command, so we have the ability to control that. So one of the objectives of the project is to test the efficiency of these solid adsorbents and to look at how long it takes before they're saturated and before they need to be replenished, and try to optimize those parameters. One of the main advantages is that if you make the material selective, you can only absorb that particular material, which makes it a lot easier to extract it and recycle that material. You don't necessarily have to stick to one type of adsorbent. You can kind of tailor that for the application. So for instance, you may look at it to absorb lead, arsenic, ammonia, a lot of unwanted byproducts from various manufacturing facilities that could be used. And then you could even take that material and recycle it and use it for other applications. We're primarily looking at activated carbon. We're looking at a couple other options. In particular, what we're interested in absorbing would be sulfur dioxide, which is commonly exhausted in coal burning power plants, nitric oxides, which occurs in any kind of combustion process where you have high temperatures, also carbon dioxide. Obviously, any time a combustion process will generate carbon dioxide. And we're also looking at fly ash, which is just a byproduct from coal burning. We'll introduce that into the flow stream before it comes into it, and we'll measure these quantities both before and after to determine how well the system is operating. In the current scope of the testing, we're targeting applications outside power plants, but this is not necessarily limited to power plants in the sense that any kind of power generating facility could utilize this. A lot of major manufacturing facilities may have combined heat and power generation on campus, and they can generate their own power, or even in oil refineries out in the ocean, they have gas turbines on board that they use to power their facilities, and so you could install this system right behind it. We're also, in future work, may look into using direct air capture to capture carbon dioxide directly out of the air, which would be a great benefit because then you're not limited on where you install these systems. You can install them anywhere.